Hello again everyone, welcome back to ptet.chemistry channel. So this is work 2 that is associated with the topic chemical formula and equations. It's quite a simple one-page work, however it involves recollection or recalling what you know about common formulas based on the names. Which looking at the first one, you have nitric acid. There are altogether 3 common acids that you have to know. One of them is hydrochloric acid. Make sure you can spell it. Hydrochloric acid. The formula is HCl. It will give you chloride salt when the acid reacts. And then the other one is sulfuric acid. Until you actually write it down somewhere and make an effort to actually cover this and actually use it, you will not remember it just by someone telling you or just by reading it. Okay, you have to pronounce it, you have to write it. H2SO4. Nitric acid is HNO3. That will give you nitrate salt. Nitrate salt contain the anion NO3 minus. Chloride salt contain the anion Cl minus, and sulfate salt contain the anion SO4 2 minus. Now the formula, well, they just want the formula, so it's HNO3 there. I don't really need to write the formula there. The element present, so there's 1 hydrogen, there's 1 nitrogen, and there's 3 oxygen. So there's hydrogen, nitrogen, oxygen. How many atoms of each element? 1 hydrogen, 1 nitrogen, and 3 oxygen. No number there, meaning 1, meaning 3 oxygen atoms, just like that. Next up, calcium carbonate. Perhaps you need to know the formula itself. You can't really just remember every single thing, but the fact is you have to remember the formula of the acid like HCl, H2SO4, and HNO3. For things like calcium carbonate, you have to work it out. Calcium 2 plus being a group 2 metal, they form a calcium 2 plus ion. Carbonate is one of the many polyatomic ions you have to remember. There's the sulfate, there's the nitrate, and then there is the carbonate, CO3 2 minus carbonate. Okay, make it a habit of actually writing down in your own personal book or your own notes so that you remember them by writing, by doing, and not just by listening or by reading. It doesn't really work that way. Oops, I beg your pardon. It's not the ions that we have to cross multiply. Bring down the valency. The valency is the charge, so the charge is plus 2, so the valency is 2, and the valency for carbonate is also 2 because of the charge there, 2 minus. So you bring down the valency, so 2 and 2, so you cross multiply, but when you cross multiply you get 2 and 2. However, this is not the simplest whole number ratio, not simplest ratio yet, not simplest ratio yet. So you need to make sure that you simplify further. You can divide by 2 both sides. You get 1:1. This means there's 1 calcium 2 plus. This means there's 1 CO3 2 minus. So you're going to get 1 calcium and 1 CO3 2 minus. You don't need a bracket because it's just 1 and 1 of each. So altogether, when you read the formula, it's going to be 1 calcium, 1 carbon, and 3 oxygen. So there is calcium, there is carbon, there's oxygen. There is 1 calcium, there is 1 carbon, and there's 3 oxygen. Okay, so again, this valency method is very important provided you know how to get to the formula of the ions itself. Ammonia is NH3. Just to remind you, this is actually from your covalent bonding topic. Nitrogen will share 3 out of 5 outer shell electrons. So these are the dot and cross that always come out, and you gotta try and complete the outer shell. Nitrogen is in group 5, so they will share 3 electrons in order to complete outer shell, to fully fill outer shell. They share electrons because their partner is non-metal. Non-metals and non-metals, they form covalent bond, which is basically sharing these electrons, one from nitrogen and one from hydrogen. The hydrogen is in the first shell, so by sharing another electron, the first shell is full, the first shell is full, the first shell is full. The hydrogen atoms are happy. The nitrogen is in group 5, so it shares 3 out of the 5 valence electrons, the outermost shell electrons. Then you share 1, 2, and 3. 5 plus 3 you get 1, 2, 3, 4, 5, and then 6, 7, and 8. The nitrogen is happy as well. So whatever you do, you count your outer shell electrons. There is nitrogen, there is hydrogen. So what happened then is there's 1 nitrogen and 3 hydrogen there. Next up, there's actually a wrong spelling here, so you should complete the thing with the right spelling. It should be sulfate. So what happened there is this is an ionic compound containing metal ions as well as the non-metal. Sorry, it's not a non-metal. It's a polyatomic anion. So let's try and find some space to do it. Na plus and then sulfate come from the H2SO4 as the salt. SO4 2 minus is the sulfate anion. The charges on the ion is the valency. So there's 1 and there's 2 there because the charge there is -2. So, the valency is going to be 2 there. So what you do next is you cross multiply. You cross multiply the valency and then 2 goes on the left, 1 goes on the right. This represents the number. How many of these do you have? So you will have 2 Na plus, so this means Na plus and Na plus, and 1 means 1 SO4 2 minus. So you got 2 Na plus or 2 sodium, and you got 1 of the SO4. So I don't need a bracket around the SO4. When you read this, you will have sodium, sulfur, and oxygen. You have 2 sodium atoms. You have 1 sulfur, and you have 4 oxygen. This is called sodium sulfate. Okay. So next up, what you have is aluminum sulfate. So it again contains sulfate. You might want to change it to the modern spelling, SULFATE. What next is you have Al3 plus and SO4 2 minus. The valency follow the charges on the ions, and then you cross multiply the valency. So 3 on the left hand side goes to the right hand side. 2 on the right hand side goes to the left hand side. What does this number represent? This one means there are 3 times SO4 2 minus. Usually I'll write SO4 2 minus, SO4 2 minus, SO4 2 minus, but I'm trying to save time a little bit here. So there are 2 times the Al3 plus. So there are 2 of the aluminium and there are 3 of the sulfate. There are 2 of these and there are 3 of this whole thing. So we're going to read very carefully now. There is aluminium, there's sulfur, there's oxygen. There is 2 aluminium, sulfur, there is 1 sulfur inside the bracket, but altogether you have 3 of them, meaning to say you have SO4 2 minus, SO4 2 minus, and SO4 2 minus. You have 1 sulfur, 2 sulfur, and 3 sulfur. That's how you read it. You don't want to write this all the time. You need to know how to read from the formula itself. 1 times 3 is 3 sulfur. Onto the oxygen, if I just label with the black color here, there are 4 oxygen, another 4 oxygen, another 4 oxygen. So altogether there are 4 plus 4 plus 4. Or you can imagine it as 4 times 3, which is actually 12 oxygen atoms there. Next up, for magnesium chloride, so I don't want this arrow, I guess. I can just write down F, part F. Magnesium chloride, Mg2 plus, Cl minus. So 2 for the valency of magnesium, 1 for the valency based on the charge on the chloride. So cross multiply the valency and you get 1 and 2. You should be able to do this much quicker now. So the 1 on the left means there's 1 of this Mg2 plus, so like that. And the 2 there means there's Cl minus and Cl minus. Altogether, there is 1 magnesium and 2 chlorine. So magnesium chlorine like that, and then, well, you call it magnesium chloride because it's Cl minus, because you already complete the outer shell by gaining 1 electron there. So there's 1 magnesium and 2 chlorine atoms. That's what you do when you count the atoms. Part G, you have ammonium, and again, you want to change this spelling to the SULFATE, sulfate. Ammonium is NH4 plus. None of these will be given to you in an exam. You're expected to remember the formula of these common ions. So make sure whatever you do that you actually do try and remember everything that the syllabus expects you to. The valency follow the charges on the ion. The valency follow the charges on the ion, and that is what you cross multiply. So 2 goes there and 1 goes there. So it means you have 2 of the ammonium ion like that, 2 of them, and then 1 of the sulfate. So you have 2 of the ammonium. I have to use bracket because there are many atoms. So use bracket and then there are 2 of it. And then there's 1 of the sulfate. I don't need to use bracket because there's just 1 of it. +1 and the +1 is +2. Cancel out the -2 charge. The whole idea is to cancel out the charges of the cation and anion so that my compound, my ionic compound or even my covalent compound can never ever have any charge at all. So how many elements we have here? We have nitrogen, hydrogen, sulfur, and oxygen. I think we run out of space for one of these. So what I'll do is I will just create another line there. Nitrogen, let me use another color so that it becomes clearer. Nitrogen, hydrogen, sulfur, and oxygen. So there are not just one nitrogen, one inside the ammonium unit, but there are 2 of them. Remember, there are 2 of them. So there is 1 there and 1 there. Okay, 1 there and 1 there. So you have 2 nitrogen. You have 4 hydrogen here, but 4 times 2 give you 8 hydrogen. As you could see, if I go here, I have 4 and 4. I have 4 and 4 hydrogen, so 8 altogether. I have 1 sulfur and I have 4 oxygen. So 1 sulfur and 4 oxygen. Okay. The last one is on the molecule. So methane, the name itself, you got to learn that, it's your case study. It's basically CH4, carbon and hydrogen. These are non-metal and non-metals. Back in bonding work 4, I've shown you how to combine these, and also as well as in the lesson associated with that covalent bonding topic, we talk about the outer shell configuration. This is the electronic configuration, and then how many electrons to share. How many electrons to share to complete the outer shell. You have 4 electrons in the outer shell, you want to share 4 more. You have 1 electron in the outer shell, you want to share 1 more because your first shell can only fill up to 2 electrons to be full. What you do then is you cross multiply because it's the number of the atoms, just like what we did for the ions. These are not ions, these are atoms, because the atoms share electrons to give you covalent compound, covalent bond, whereas these are ionic bond where you have transfer of electrons and you have cation and anion, so you get ionic ions, meaning ionic compound. But CH4 contain atoms, not ions. They share electrons, but the idea is the same. You cross multiply because this then tells you there is 1 carbon and there is 4 hydrogen. There is 1 carbon and there is 4 hydrogen. I'll just very quickly show you the dot and cross. Dot cross hydrogen, dot cross hydrogen, dot cross hydrogen, dot cross hydrogen. Or in other words, you can draw them as lines. This is not dot and cross. If a question asks you dot and cross, you must be able to convert this line. 1 line is 1 covalent bond. 1 covalent bond is 2 electrons being shared. So 1, 2, 3, 4. 4 covalent bond is 4 times 2, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. 4 of them come from the 4 outer shell electrons of carbon, and another 4, each one come from the each of these hydrogen, of which there are 4. So each of the hydrogen share 1 electrons, then that contributes another 4 electrons to this one. Therefore, the carbon has fully filled outer shell. That is the purpose of bonding. There's 1 carbon and there's 4 hydrogen. So that's the formula of methane. Along with methane, there are some other covalent compound, the formula of which you must know, stated in the syllabus: HCl, H2O, NH3, CH4, and I forgot one more, CO2. So these are very, very common stuff that the Cambridge examinations, they like to ask you to draw dot and cross. They like to give you the name and you must be able to state the formula, or sometimes they give you the formula, you must be able to state the name or identify them very easily. Okay, that's it for this tutorial. Please click the button on the bottom right to subscribe to the channel, and follow me at ptet.chemistry. That's ptet.chemistry on Facebook, Instagram, and Twitter, and to get connected. And please share the channel widely with all your friends, chat group, juniors, seniors, teachers, students, relative, whoever else you think might benefit from the tutorials on the channel. So do browse around for other useful topical playlists as well. And just make sure that you know you're looking for 5129 combined science, or if you're looking for the 5070 pure chemistry contents. There are also A-level contents if you know someone who are doing their A-levels or their IB chemistry. Thank you for watching. See you in the next tutorial video.